All right.
So match each expression with an equivalent expression is the first question.
So we have to show work for these two, right?
Yeah.
Yes.
Okay.
Well, the first one wouldn't just be C because the sine of negative x equal to negative sine of x.
Yeah. That's what I was thinking.
Sine minus sine.
Oh.
And B, or the second one, would it be A? Sine minus sine. B.
Wait, so when you do your sine minus sine, you get 2 cosine sine? That's the identity?
Yeah, so the identity for that would be 2 cosine parentheses x plus y over 2 parentheses times sine parentheses x minus y over 2.
Okay.
So
So what did we decide on the first one?
the first one was B. No, it was C, sorry.
Second one.
Yeah, so 6 plus 4 over 2 times sine 6 minus 4 over 2. That's equal to 2 cosine 5 times sine. Yeah.
So the third one be E?
I'm not sure what's the identity for that one.
I thought it was equal to tangent squared, but I guess not.
Oh, you're still on the second one?
What's that?
You're still on the second one?
We're on the third one.
What was the second one?
It was A.
You guys are smart.
So you just use the sum to product identity, where sine x minus sine y equals 2 cosine x plus y over 2 times sine x minus y over 2. That to be that 2 cosine 5 times sine 1.
Now you're on the third one?
Yeah.
Cosine squared of 6. If I'm not mistaken, cosine squared of x over 2. Actually, no. So cosine squared of a of a variable minus sine squared of a variable equals cosine of 2 times the variable. So it's going to be B.
B. I gotta write it down.
Which one is it?
B.
It's B.
That's 12.
It's an identity, I think, is cosine squared of something minus sine squared of something equals cosine of 2 of that, like cosine of 2 times that. So cosine of 2 times 6 equals cosine of 12.
Cosine 6. So this is cosine minus cosine. Cosine minus cosine is minus 2 sine x plus y over 2 times sine x minus y over 2.
That should be D, right?
Yeah.
Okay.
Who's gonna send in this quiz?
I can.
Okay. You want to just like show the work for it, how we got it?
Yeah. Doing it right now.
Art. Eh?
So then that means the last one would be E.
Yeah, how do we find that? 1 plus cosine of 6 over 2. How does that equal to?
Isn't it just the opposite of what we did for? Actually, maybe not, because there's a sine squared. I was going to say for the third one, maybe the opposite, the reverse,
Yeah.
but I don't think it is.
Do you have that identity written down, Curtis?
What's that?
Do you have the identity for this one?
Which one?
The last one.
I'm still writing the last one.
Okay.
Sine of 5, sine of 1. Okay. 1 plus cosine of 6 over 2. What are we doing for this one?
Yeah, we know it's E, but we're just trying to figure out like what the identity is. All of it.
Oh, gotcha. Let me see. Yeah, that's might be 1 plus cosine of something over 2 is that's going to be cosine of x over 2 squared. So x in this case is 6, so it's 3 squared. So cosine squared is 3. It's one of the half angle identities. The cosine of x over 2 equals plus or minus the square root of 1 plus cosine x over 2.
Yeah, I know. I remember.
Proofs, huh?
So what about, since it's squared though, is it still the same?
Yeah,
Okay.
it's just going to be cosine squared of 3.
Oh, okay, gotcha. And then you just divide the angle or whatever in half.
Yeah, because it's 6 over 2. It's x over 2, so an x is 6 in this case.
Gotcha.
Because it's the cosine of that number squared, not the number itself.
Okay.
Go to the book and kind of look at how they did their proof.
On number 2?
Yeah.
My dog just tooted. Smells really bad. Which chapter is this in the book?
That's what I'm trying to figure out. Is it 6?
I don't know.
Yeah, it's chapter 6.
Yes.
Okay. So I don't understand. Okay.
Ran out of power. The product to sum.
Yep. You just take one of the identities, add them together, and something on the right side would cancel out.
Did you find it?
Yeah, I'm looking at it right now.
Which page is it on?
459.
459.
Yeah.
What's that?
Oh, so you use one of the cosine of a sum or something.
Yep.
So which one did they use?
Use the first two, where it's sine A plus B equals sine A times cosine B plus cosine A times sine B, and sine A minus B equals sine A times cosine B minus cosine A times sine B. You added those two together. And then the two cosine A is canceled out. She left with 2 sine A times cosine B. And you just get to divide by 2, take 2 off the side.
You got 1/2 sine of A plus B plus sine of A minus B. Cool. So the other ones could be found a similar way. That's what they're saying. So that one is the first one.
We do the 3 and 4. What do you want to do?
Do we have to do 1 or 2?
I think it's just at 1.
So they added together the sine of a sum and the sine of a difference, so we could try adding together the cosine of a sum and the cosine of a difference.
Yeah.
Maybe see what happens.
That should give you A plus B.
Cosine of A plus B equals cosine of
A minus B equals cosine A to cosine A cosine B. Divide it. It's 1/2 cosine A plus B plus cosine A minus B is equal to cosine A times cosine B.
Wait, so they divided the one by the other in the
They just
proof?
divided by 2 to get rid of the 2 on the right side.
No, before that, when they were combining them. No, oh, they added them together.
Added them together.
Oh, gotcha.
So just the
Cosine of alpha, cosine of beta, cosine of alpha.
negative and positive should cancel each other out.
Right. So it's just going to be cosine of alpha, cosine of beta.
Yep.
Or, I mean, 2 cosine of alpha, cosine of beta.
Yeah, and divide the other side by 2. Or both sides by 2. Give you 1/2 cosine A plus B plus cosine A minus B.
Okay. Everybody get that?
Yep.
Find all the angles alpha that satisfy the equation of sine. Alpha equals a tangent of alpha.
So sine 2a is a double angle formula, right? So it becomes 2 sine A cosine A.
Yes.
Just use the reduction formula for this one, or
The what?
the reduction formula?
Maybe.
X is an angle, terminal side.
The only thing is we don't have a point or an angle for the reduction formula.
How do we find this one then?
Let's see. The sine 2a becomes 2 sine A cosine A equal to tangent A would just be sine over cosine, sine A over cosine A. I mean. So here, I'll send you guys a picture. I think I figured it out. Maybe not. Um, so yeah, this far, I don't know if I'm on the right track. Maybe you guys could help me out. So,
Well, you got it down to 2 sine of alpha cosine of alpha equals sine of alpha over cosine of alpha. And then what did you do?
that's why I'm sending you guys the work of. I just took a picture of it. It should be sending right now. Did you guys get it?
Just
Yeah.
Okay.
Wait, what?
The only thing I can think of is to like try and get it equal to 0, but I wasn't sure how to do it. I guess you could bring out 2. I don't know.
Where'd you get the 1? And why did you divide by sine of alpha?
To get it to the other side, because I'm trying to get the numbers to one side so that it's like sine or cosine theta equals like 1/2 or whatever the number would be. And sine alpha divided by sine alpha equals 1.
Where did the cosine of alpha go on the denominator?
The cosine of alpha multiplied it. So then it came cosine squared.
So I guess if you had 2 sine alpha cosine squared alpha all over sine alpha equals 1, then you could factor out the 2. So 2, and then put everything else in parentheses. And then the sines would cancel out. So would it be 2 cosine squared alpha equals 1? Divide that by 2. So it would be cosine squared alpha equals 1/2. I'll write it out and send you guys another picture.
No, that makes sense.
Okay, because I can't think of any other way to solve this problem, honestly. Give me 1 second.
The sine of alphas cancel each other out, right?
Yeah.
All right, here, I'll send you what I got. All right, sending.
I'm not really understanding this at all, this part. Like I get, how come there's like, it's 2 sine alpha, cosine alpha on the left side?
That's an identity.
How is it?
Sine of 2 alpha is equal to, where is it? It's a double angle identity, I think. Yeah, sine of 2x equals 2 sine of x cosine of x.
Okay.
Equals 1/2. But what do we do with that information?
Take the square root of both sides, break it down to cosine alpha equals root 2 over 2, and then take the inverse of that, which would give you the angle. So root 2 over 2 cosine is equal to there's pi over 4 or 7 pi over 4.
How are you able to take factor 2 out when there's no 2 on the bottom? Just 2 on the top.
Well, because it's the numerator.
Okay, so now what do we do with the points that are given?
With the points?
Yeah, 0, 2 pi.
Well, so I think it's just asking for all the angles that are within 0 to 2 pi. And so that would be pi over 4 and 7 pi over 4. Because those are the only points or the only angles.
2 is the x value.
Yeah. At least that's how I thought we were supposed to solve it. That's what I did.
Michael's a genius. So then we can plug it back in.
See if
The
it.
sine of pi over 4 times 2. Or pi over 4 times 2 and the sine of that. Yeah.
Yeah.
So that'd be pi over 2. So 90 degrees, the sine of 90 degrees is 0. And the tangent of is not 0.
Wait, it should be instead of pi over 2, it should be. Actually, never mind. You guys are right. My bad. Thinking of something else.
So sine of 2 times pi over 4 equals 0, right? Sine of pi over 2.
I'll be back. My boy just let it blow up.
That's all right. A tangent of over 4 equals, that'd be root 2 over 2 over root 2 over 2. So that's equal to.
Wait, the sine of pi over 2 is 1.
Oh, you're right. I'm thinking cosine. Yeah. Okay, that one works then.
So we just got to figure out if 7 pi over 4 works.
Yes.
It does. Oh.
Pi over 2. 3, 4, 5, 6, 7. I don't think it works. Wait, maybe. Yeah, it does.
Sweet. It's a miracle, guys. Holy cow.
Job. Find the exact.
Okay. Cool.
All right, number 4. Exact value of the expression. Any ideas how to do this one? I have another clue.
No. You can use a sum to product.
Yeah, sine x minus sine y.
Yeah.
Yeah.
That sounds like a good idea.
It's going to be 2 cosine of x plus y over 2 sine of x minus y over 2. Should be 285 plus 15 is 300 over 2 cosine of 2 times the cosine of 150. Sine of 135.
150, 130.
150 is 30 degrees. That's its reference angle, and sine is that's 35. 135 is 45 degrees. So
How'd you get 135?
what?
How'd you get 135?
285 minus 15 is 270 over 2.
Okay.
Yes.
So cosine of 150 equals negative root 3 over 2.
Yes.
And the sine of 135 equals root 2 over 2.
We're looking for like a radian or decimal expression, or
Those exact values, so probably radian.
Yeah.
If you do decimal, you're gonna have to round. So it's negative root 3 over 2.
Yeah.
Okay, sweet.
Wait, did you say negative root 2 over 2?
No.
I thought it was.
It's root 2 over 2. I said negative root 3 over 2.
Okay. I agree.
Awesome. I think that's all the problems.
What does that equal?
What, negative root 3 over 2?
No, when you multiply them all together.
So you multiply the 2, the root 3 over 2, and then the root 2 over 2, and it all equals to negative root 6 over 2.
Negative root 6 over 2, doesn't it?
Yes. That's what I said. Well, that's what I thought I said.
Can it be? No, it can't. Okay, cool.
Awesome.
what was the final answer for that one? You guys got
Negative root 6 over 2.
to take my calculator off radians and just put it to degrees, and it worked out.
Yeah.
Cool.
Awesome.
So yeah, you guys want to like check our schedules and see when we could meet or something to review for the final sometime after this next test. And then I could text the TA and see if she could meet with us too.
I can really make anything work because I'm really flexible with my work schedule and my class schedule. So.
Did you guys want to meet like one time for like an hour, one time for a couple hours, or like a few times for an hour? Like, what were you guys thinking?
Did like twice for an hour each or something.
Okay, I like
we don't overload ourselves.
Right.
Yeah.
Maybe we could just go over like the first time, since I guess there was 4 tests in the unit or in the whole semester. We could do like, we could each review things that we had problems with or that we want to review from the first 2 tests, and then put that in the first meeting, and then do anything that we want to review from the 3rd and 4th test in the second meeting or something.
Okay.
All right, sweet.
When would this be?
We haven't figured out a time yet, but
Because we're in week 11, right?
we
And
still
the
have another test
test
next week.
is the exam due tomorrow?
Yeah.
Yes.
Everything else?
I think 4B is due end of this week or something like that.
4B is due
2
in
weeks.
week 13.
Okay.
Yeah.
A little bit.
We get a week off of tests,
Sweet.
and then week 13 is 4B, and then week 14, I guess, is the final.
Yeah.
Yeah, so we could probably just meet anytime after exam 4B. Maybe give us like that weekend break or something, and then come back at it the next week and meet.
Yeah.
Cool.
So, cool. Well, see you guys later.
Good.
Yeah.
See ya.